welcome to the PhysicsPlace, the place to learn about physics. And in this video we are going to see what the resulting force is and what the effect on a motion will be. So we have a car here and we have a force forward, the engine, we have a force backward, different kinds of frictions like air, resistance and tires. And we will see what this will have for an effect, because this situation is different than this one, and that's all again different than this one. And they're all different situations, and you will be able to tell at the end of this video what kind of effect on the motion these arrows will have. First we will start with this example. This car is moving forward. When it's moving forward, the engine has a force forward like this, and because of frictions there is a force backwards, like air resistance. The tires also have resistance. It's a small force, and as you can see, the FR, the force, the resulting force is now forward. And when the resulting force is forward, the car will be accelerating. So it is already moving forward and it will go faster and faster. Now, if it goes faster, also the frictions will go up. So the air resistance goes up, the tires will have a bigger resistance. So this arrow will become larger and larger to a certain moment that they will be equal of length. Doesn't mean that the car stops. It still is moving forward, but it's not accelerating anymore. It's going at a constant speed. So for instance, 60 miles per hour. Then if you let go of the throttle, so there is no more engine, or the engine will go a lot less, then you will see that the force forward will be a lot less. All the air resistance, tire resistance will still be there. It doesn't mean that the car is going backwards. The car is still moving forward, but it will be decelerating. So you will go slower, slower and slower. If you go slower, you can imagine that this arrow will go smaller and smaller until it will be the same as this one. And then you will go at constant speed again, but you will go slower than you were going here. So in summary, if the resulting force, the FR, is in the same direction as the movement, then we are speaking about acceleration. That's like here, because the FR, the resulting force, will be to the right, which is also where the movement is. If the resulting force will be 0 newtons, we are talking about a constant speed or stationary. If you know that this car is moving, then it will be at a constant speed. If it's stationary, it will stay stationary. If it's going opposite of the direction of the movement, like here, then we are talking about deceleration, so it goes slower, slower and slower. Of course, when this car finally stops and there will still be a force to the left, then it will start accelerating to the left again. The 0 Newton, it's a strange one, you have to remember this one. It's also the first law of Newton. An object either remains at rest or continues to move, like here, at a constant velocity unless acted upon by a force. Here there are forces, but they equal 0, so we do not say that it's acted on by a force, so therefore it will go further on a constant speed or stationary. If we look at this book is laying on a table and there's a few forces acting on it. Of course, the gravitational force downwards, and if this would be the only force, then the book will actually go down, because then the resulting force will be downwards and the book will go down, but it's not. It's laying here stationary, so there must be an equal force in the opposite direction. In this case, it's the Fn. It's a very important force. You don't actually see it. It's a reaction force. You don't notice it unless something is put on the table. It's called the normal force, Fn. It's exerted by the surface on the object, so it's exerted by the table onto the books, and it's perpendicular to the surface. So always in a straight line up and 90 degrees to the surface. And it's a reaction force, so the greater the Fg will be, the greater the Fn will be, and it will always be equal, unless the Fg will be so great that the table cannot exert a greater Fn, and then the table will simply break. So the normal force is a force which is a reaction force to, in this case, the Fg, but it doesn't need to be the Fg. For instance here, this guy is leaning against this pole with a certain force. He's not falling through it, he's just stationary, and if he's stationary, then you know that the resulting force is 0 newtons. So there's an equal force the other way. Again, Fn is now 90 degrees on this surface, so it's perpendicular to the surface, and this is the normal force, or Fn. Another example, this car, it's moving forward at a constant speed. You can see that it's a constant speed because the force forwards and the force backwards are equal, so the resulting force is 0 newtons. And if there is wind blowing, then there will be an extra force, in this case to the left. So these two forces, they cancel each other out, so he will still go with the same speed forward, so no acceleration or deceleration, but there will be an acceleration to the left. So he will start to turn to the left because there is a resulting force to the left, which is not cancelled by one of these two. Therefore, you need to steer to the right, so there will be a force to the right, and then it will be cancelled, and then you will keep on going straight. So the resulting force to the left causes the acceleration to the left. So even if you are going forward, if you have a force going not in the same direction or opposite but left or right, then you will be accelerating in that direction. An example question. The penguin is parachuting. Determine if it is moving at a constant speed, stationary, accelerating or decelerating. So if a penguin, he just jumped out of this plane, luckily he has a parachute, and you can now determine what kind of movement the penguin will have at every situation. So try it now for yourself. Pause this video. First we will look at this one. You see that there is a force downwards. He is also falling downwards. That's normally where things fall when they jump out of the plane. So this one is accelerating to the earth. Now you can see that these forces are equal. So he's going at a constant speed. He could also go stationary, but yeah, there's nothing to hold him up, so he is going at a constant speed. He's falling. The parachute is opening. There is a very large force upwards, so now he is decelerating, which is good because he is falling very fast here, and now because of the parachute he first will decelerate. Now he goes a lot slower, but at a constant speed because they are equal. And here again, constant speed, but you can see that he's standing on the ground, so he's actually stationary. So this is how you use the knowledge you just gained to determine the different kind of movements. Another example. This car is moving forward, and you can determine if it's moving at a constant speed, stationary, accelerating or decelerating. So you already know it's moving forward. So now we have to determine the resulting force, and we have here some forces. Forward is the one here, 4.0 kilonewton, so 4,000 newtons. And then we have these forces who are also opposing it. So the opposing forces are 1.8 here, kilonewton, and 2 times 1.6. That equals 5.0 kilonewton. And now we can determine the resulting force. So the resulting force, Fr, is 4 minus 5, so it's minus 1.0 kilonewtons. Why minus? Because the forward motion of the forward force is smaller than the opposing forces. So there the minus says that it's going the opposite direction than the movement. So Fr, the resulting force, is opposing the movement, and that means that the car is decelerating, so it will go less and less fast. It doesn't mean it's going backwards, because it says here the car is moving forward, but it will be decelerating. And of course, when decelerating, probably these forces will go down, and then after a while it will go at constant speed. That's it. I hope you found this helpful. If so, please like and let me know that you found this helpful. And of course, don't forget to subscribe for more videos. Thanks for watching.